Good afternoon. It's great to be here. First South Summit for me. Great to be in Madrid. I'd like to welcome the panelists, Tamara, Amos, and Salvador. And the first question I have is the activities of your company, Protiopower, and also how it fits into the hydrogen ecosystem. So, Tamara.
Yeah. Yes, well, so first of all, thank you so much for this invitation, because I love to discuss about hydrogen, and I think that today is a very good opportunity. Regarding Protiopower, it's a company that was born in 2011. We are based in Bilbao, in the north of Spain, and we design, develop, and produce fuel cell systems for different sectors. As you all know, a fuel cell is a system that, using hydrogen and oxygen from air, produces power and water, and that's it. I mean, that's it, because we have no CO2 emissions, no NOx emissions. We just have power and water. Regarding the sectors Protiopower works in, we have the stationary applications. For example, we are building the biggest fuel cell system in Spain. We are putting a 65 kilowatt system in Bilbao in the new facilities of Petronor. So it's going to work as a backup for the office building. And on the other hand, we also work in mobility sector. And I always like to say that mobility are not only cars. When I talk about mobility, I talk about forklifts, planes, ships, submarines, or whatever. For example, we are working in a project that consists on putting a fuel cell system in a UAV. So the challenge here is not only to design a system that works properly, but also to save mass, because in aerospace, mass is very important. So our expertise is related to the design of the engineering and the balance of plants, and to optimize all processes around the fuel cell to comply with each requirement of each application. Mm-hmm. And regarding the hydrogen value chain, we are positioned at the end, where the uses of hydrogen, because as I said before, we use this hydrogen to produce clean energy with the fuel cells.
Mm-hmm. Yeah, thank you for the explanation. Then Amos, I understand you're working on hydrogen in marine applications, naval applications. Can you tell us a little bit about what you're doing?
Well, first of all, I would like to thank the organization for inviting us to participate in this event. It's my first time, and my first time here in the South Summit, and I say it's quite impressive. So you may know Navantia, because it's a national ship builder. We have wide experience in ship design and also in system integration. But now we have created Navantia Synergies, which is a new division of Navantia, which is really focused on clean energy promotion. So what are the assets of Navantia Synergies? So we have all the business related to offshore wind. So we do foundations, we do substations, but we also have gathered there all our assets in hydrogen on the company, just to develop this hydrogen business. What are these assets? So we have very important industrial capabilities. So we are thinking being as an industrial partner for assembly of big electrolyzers. We have our engine factory, so we are quite close to the engine designers and the new developments for the new vectors. And of course, we have all the capabilities and knowledge that we have acquired doing special applications for defense using hydrogen. As Tamara has said, we are talking of the S-80 submarine. We have developed this air-independent propulsion system, which basically is a system that allows to extend the endurance of the submarine when it's diving underwater. We can recharge the battery using a fuel cell, which is fed with hydrogen generated from bioethanol on board. So all this system generates power, and all the residues of this power generation is just CO2, which is diluted in seawater, just to have don't affect the steel of the submarine. So our plan is taking all these capabilities, channeled through our new Green Energy Center of Excellence with two ideas. First, We plan to contribute to the decarbonization, providing new solutions based in zero emission or neutral emission fuels, using fuel cells, using engines, just to help to the decarbonization of the sector. And on the other hand, we have a goal, which is having these technologies scale, industrialized, and ready to market by the end of this decade. This is our plan.
Yeah, it's super interesting. And then now we're going from naval applications to ports. So Salvador, can you tell us about your activities at Valencia Port?
Yeah, sure. Good afternoon, everybody. Well, Fundación Valencia Port and OpenTop, we are the research and innovation hub of the Valencia Port cluster. So we are involved in many innovation projects of many different fields, always related to port and logistics. But the Port of Valencia has the ambitious goal to become net zero emissions in 2030. And this is why many of the projects we are involved in at the moment are related to this objective. So in order to reach this objective, it is necessary to apply technologies that are not at the moment mature enough. So as Fundación Valencia Port, we've been working in the last period for testing candidate technologies and supporting them in their journey to reach the commercial stage. And one of the examples of this work is, in this case, related to the hydrogen application to the port environment. And here we are coordinating the H2Ports project. This is a Horizon Europe project in which the hydrogen versions of two types of equipments that are used in port operations have been developed and are being tested in real operational conditions. More in particular, Hyster-Yale has developed an hydrogen power reach stacker that is being tested in the MSC terminal at the Port of Valencia. And Athena has developed a terminal tractor, also powered with hydrogen, that is being tested in the Grimaldi Ro-Ro terminal, also in Valencia. Also, the solution to supply hydrogen to this machinery has been developed by the Centro Nacional del Hidrógeno. And in both cases, is the first worldwide experience for this type of machinery. Mm-hmm. So we are expecting to have the results after this period of testing in real operations.
Okay. When do you expect to complete the testing?
It will be 1 year testing.
1 year testing.
So
okay.
To get the better conclusions possible.
Okay.
So during all this year, they will be operating in these two terminals.
Okay. Great. So before we move to the next question, I'd like to explain a little bit what we do at 1S1 Energy. So we're developing next generation technology for the production of green hydrogen. Green hydrogen means that we're using renewable energy to split water into hydrogen and oxygen. And our approach, which we are developing both in California and Portugal, is to innovate on materials to increase efficiency, durability, and robustness of the hydrogen production. So that way, we believe we can get to lower barriers for adoption, producing hydrogen at a levelized cost below $2 per kilogram, and also provide a solution that is robust and easily serviceable. So now we're moving to the next question, which is Tamara, what are the opportunities and challenges that you see in this sector? Yeah.
Well, so if we start talking about opportunities, I think that today hydrogen has almost all opportunities because it's the fashion. I mean, when I started working in hydrogen 12 years ago, nobody talked about hydrogen, but today decarbonization is a must in Spain, in Europe, worldwide, and also we need to decarbonize all sectors. industry, residential, transportation. So I think that there are many opportunities today that we have to take care about it. Regarding to highlight one of the advantages of hydrogen, I think that we have to look on the opportunity we have storing this hydrogen for a long time. We can store big amounts of hydrogen during stationary periods. And this is a very good point because we can use this hydrogen to produce power whenever we want. So I think it's an important good point for hydrogen. And I don't want to say with this that hydrogen is better than batteries or than supercaps or whatever. I think there is room for all, but for sure, hydrogen is an important tool for decarbonization. And on the other hand, regarding the challenges, if I look in my business in the fuel cell sector, I think that we need to grow, and I think we need to improve our capacity of production because we need to become competitive, not only in price, but also covering the necessities of market. I mean, today, we are supposed to produce gigawatts of hydrogen in Spain, but tomorrow we will need fuel cells and other systems to use this hydrogen to produce power. So I think that this is one of the challenges to become competitive and to grow.
Okay. And do you imagine using hydrogen for stabilizing the grid or for emergency backup type of?
In our case, we have solutions for as backup.
Okay.
For stationary applications, but it's also a possibility to combine it with the grid, for sure.
Okay. So almost the same question, what opportunities and challenges do you see?
So for giving a little bit of context, so now the maritime transport represents like a 3% of the greenhouse emission gases. The International Maritime Organization have a target of reducing that level to 50% in 2050, which in reference to the values of 2008. So that means a very big opportunity for technology developers and shipbuilders because we need the solutions to get into that. So the point here is that the naval sector is a sector which is very difficult to power with electricity. So we have to move into other solutions to meet that target. So one way to achieve that decarbonization target could be, increase the efficiency of the ships, or change the operational profiles and the way of operation using artificial intelligence, many ways. But if we add all of these things, we believe that we are not going to be able to achieve more than a 55% or so maximum of the level which is required. So to achieve the target, then we are going to have to decarbonize the fuels for the maritime sector between 40 and 65%. So that means that where the green hydrogen gets into place. But of course, there's a lot of challenges because the technologies for the maritime sectors are not ready, and there's a lot of uncertainty of getting technologies or systems that could meet their requirements to do so. So we need powers in the order of megawatts. We need endurance in the order of thousands of nautical miles, life spans of more than 30 years. So that's a difficulty in a sector which is very, very low in units. We are talking about 30,000 maybe units of heavy transport maritime. And the other challenge is that unlike the light transport, seems that we are not going to have like a single option to power the system. So the technical solution is going to depend on the size of the platform and the operation. So we are going to have many different technologies, many different fuels. So that means uncertainty and then lack of inversion because people prefer to wait and see. And the last one is how to efficiently integrate these new vectors in a safe way without a big modification of the platform. So there's a very big gap between fossil fuels and the new fuels that we need to solve. So then, what is the right fuel for the maritime sector? So we believe that treated hydrogen is going to cover a very small percentage of the energy share that it's going to need the sector. But other fuels derivated from hydrogen with higher density, liquid at ambient or close to ambient temperature, as ammonia or methanol, are going to be the solution for a better integration. They're not going to compete, we believe, between them, so they're going to be taking share from now up to 2050, from other not decarbonized fuels as natural gas, heavy fuel oil, and others. And even in the more optimistic scenario, we think that we are still going to have these uncarbonized fuels working till 2050. So there's a very big challenge, and this is a thing that's not going to be solved in the next few years.
Yeah, thank you. Thank you. And from the point of view of ports, what do you see as the challenges and opportunities, Salvador? Yeah.
Well, before talking specifically about ports, lower
or in
carbon
general,
emissions
yeah.
are achieved using renewable energies. And hydrogen is an energy vector for storing and distributing this energy the same way we can do with electricity. It's true that the use of hydrogen still has to be developed for many potential applications, and also implies lower efficiency, as there are losses in its transformation step. But it's also true that, as Tamara said, there are also many clear advantages, as the easier long-term storage, or also the possibility to use already existing networks as the natural gas, or also the easier and faster refueling operation for mobile applications. So there are opportunities there, and Amos referred to the maritime sector. I think in port operations, there are opportunities where all these advantages make a difference. For instance, there is machinery where the electrification is not easy because they require very flexible movement, etc. And in this kind of situations, hydrogen can make sense and has an opportunity there. And beside this, there are also industries that are already using hydrogen in their production processes, like refineries or the production of fertilizers, etc. And for them, one of the main decarbonization actions would be just to change the color of the hydrogen they are using, going from gray to green. So I think there are a big range of opportunities for hydrogen.
Yeah, that's a great topic and something we're focused on at 1S1. So we're looking at replacing gray and black hydrogen used for industrial production with green hydrogen. So I was doing some calculations this morning, and just providing the needs for the ammonia production, which is imperative for growing food, we would need around 200 gigawatts of electrolyzer capacity, which is huge, and it's a huge challenge. And that's very sobering. And then if you add to that hydrogen for heavy transport and other applications, that's a huge challenge. The other issue we see is that we cannot afford to have leakage of hydrogen when hydrogen is a small molecule and moves to the upper atmosphere very quickly. And when that happens, it reduces the capability of the planet to process methane in the upper atmosphere. So it may exacerbate the issue of greenhouse from methane. The other issue is that also because it's a very small molecule, it can leak. So we need to design the storage systems and piping and seals that can contain the hydrogen. And so it's a very challenging task, but something we must do. And the way to do it is through innovation. So there's a lot of uncertainty accomplishing this, and as humans, we have issues processing uncertainty. So it's important to not rush to conclusions and also focus on the innovations that solves these problems, and that's what we're focused at 1S1. So in terms of UAVs, that's a very interesting application. So do you expect to operate at higher temperatures in a UAV, the fuel cells, or?
Actually, not in this concrete project. The main challenge is how oxygen is in air at this high altitude.
Yeah.
So we are dealing with how to compress this this air to work. But we are using low temperature technology. We are using PEM technology.
Okay.
And on the other hand, as I said, there is an important challenge related to mass, because every gram you can save in aerospace is important. So we are dealing with a very good operation and saving mass.
Okay. Okay. So in doing this, Amos, in doing this transition, do you have a favorite vector or for shipping or?
Well, as I have said, we have these two candidates.
Yeah.
There are going to be more. You know,
Yeah.
we are talking. So, or some applications are talking of using pure hydrogen, cryogenic, maybe liquid. But methanol and ammonia looks like are the references now for the maritime sector. So to me, ammonia has an additional appeal, which is a fully decarbonized vector. So, and at the end, there's a very big developed industry behind. So it's necessary, for example, to generate for many industrial applications, fertilizers, and etc. So it's going to have many commonalities with the industry, with transport. Methanol requires, CO2 capture, the green hydrogen generation, many more processes in between, so there are more losses of efficiency and maybe more expensive. So they both are going to have their place, but to me, as in the very long future, I believe ammonia is going to be a right solution. But if we look into the short term, it's easier to apply the methanol because can be used in engines with some adaptations. So that's the reason, because that's the first one we are going to see on the naval sector. Maybe use it in engines, combustion engines, adapted to do so.
Okay. So methanol provides a better use model, and ammonia more efficient means of propulsion, right?
Well, at the end, methanol is going to be is neutral in carbon, which means that globally, in the Excel spreadsheet, it's zero. But locally, you're going to have CO2. So ammonia is going to be zero, no carbon emissions. So that will be the best benefit. So in terms of energy density, they are quite close.
Okay.
But they have pros and cons. For example, it's easier to embark methanol because you can have the liquid at ambient temperature. It's more complex, the ammonia, because to have a liquid, you have to have a high pressure, low temperature, below zero. So as I say, so there are a lot of challenges, but looking to future, thinking in communalities, in logistics, in no carbon, free carbon system, to me, ammonia is a very nice option.
Okay, great, thank you. And Salvador, what's next for the Valencia port, Fundación Valencia Port? Yeah.
Well,
after the pilots,
What we are going to do is to continue following all the different initiatives around hydrogen, because it's something that currently is exploding, and there are thousands of different initiatives, lots of projects, lot of efforts, lot of investment. And we want to be there to follow this and also to promote new projects and to develop new projects. in order to position Valencia Port as a key player in this energy transition and also in the development of the hydrogen economy.
Okay. Yeah, thanks. So, Tamara, any last thoughts to conclude the panel? Or, yeah.
Yes, well, I think that decarbonization is a must. We already knew it. It's not something I learned today. But I think that hydrogen race is a collaborative path. I mean, there are synergies between all players in the hydrogen value chain. For example, in power-to-power projects, in ports, for example, there are many, or airports or whatever. We need people that produce hydrogen, people that have energy storage systems, people that have fuel cells to collaborate all together to get success. So I think that it is very important to know that it is not an individual race, but a collaborative one.
Mm-hmm. Amos?
So I believe that one important thing is developing of technology. I mean, this is an opportunity for Europe. So to have this technology sovereign, we need to take this wave to reindustrialize Europe, to develop our technology, and mostly in countries as Spain. I believe it's a very big opportunity to be, the first in the class, and not being, just exporting technology from other countries. And I believe this is one of the main motives that we are, in Navantia Synergies, promoting our Center of Excellence and some initiatives as Monodon, which we have a stand today here, just to promote the technology development. I think is key, and as Tamara has said, we have to work together. We have to put our efforts on the synergies, just to share not only the benefits, but also the risks. There's a lot of uncertainty, and we need to bet in that sense.
Mm-hmm. And Salvador, any last thoughts?
Well, nothing to add. Just to say that, well, I always learn new things in every event I participate around hydrogen issues. And, thank you for the invitation.
Yeah, thanks. Yeah. And at One is One Energy, we're benefiting from a project called Important Projects of Common European Interest. We're part of the Hy2Tech wave, and that helps support the development of green hydrogen technology. So that will fund the establishment of a development and manufacturing center in Portugal. So we're very lucky to be part of that, and very appreciative of the support from the European Union. So I would like to thank the panelists. Thank you for your contributions, and it's great to be here, and thank the public for our attention. And I think we can conclude the panel now. So thank you.